What's up, everybody? Welcome back to the episode of Outlawed Motors. Today we are talking about Mini Cooper's crappy valve covers and how I found a solution to fix it, hopefully. Crossing my fingers. If you own a Mini Cooper, specifically the R56, then you've probably had one of three things fail on you, if not a few more things. The water pipe under the intake manifold, the oil line that feeds the turbo, as well as the valve cover melting, or all three of those things, which are actually far more tied together than you may think. Typically what happens, at least this was in my circumstance, was the water pipe started to fail, which I didn't catch until way later, which then the coolant system isn't working all that efficiently. The thermostat housing goes, which at that point your oil line has probably been compromised because it is working overtime and those oil lines aren't really built all that well. The oil line goes and then starts spewing oil all over the front of your engine block as well as your plastic valve cover. Newsflash, plastic valve covers can't handle that much heat, specifically when hot oil is spewing all over them. Now the good news is when your oil line goes, there's plenty of aftermarket upgrades that you can go to. I used NM Engineering stainless steel upgraded oil line, which is far better built and will withstand much more heat than the original one. That's just this kind of metal exposed hose. Unfortunately, if you melt your valve cover, you are kind of SOL and have to go to the BMW dealership to pay BMW prices to buy a $450 valve cover, and that's at a discount in Canada, which really doesn't feel good knowing that you're putting on a valve cover which they haven't really found a good solution to fixing. The problem with the valve cover is that the turbo sits right beside the valve cover and this little pocket where there's just a lot of heat that builds up. And the biggest issue is that being plastic, that thing is only going to withstand so much abuse before it gives. So just buying a new one wasn't a good enough solution to just put it on knowing that the same problem could easily happen, especially because I'm running a bigger turbo and there was already a heat issue in the first place. I've already ceramic coated the turbo and the downpipe, and I'm going to be putting more heat shielding around the turbo. However, I want to make sure that I minimize the chances of the valve cover failing because I don't want to buy another one. So what I did was I partnered up with Heat Shield Products, which they hooked me up with their Cobra Shield, and we went to work on putting it on to the valve cover. The reason I chose to use Heat Shield Products Cobra Shield is that it can withstand continuous heats of 1100 degrees Fahrenheit and 2000 degrees Fahrenheit intermittently, which if I get to those temperatures, I've got other problems. Typically, to apply the Cobra Shield, you would take an adhesive spray and apply it onto the surface you are trying to radiate heat away from, and then press the Cobra Shield onto that surface. However, because we're using the Cobra Shield on a valve cover, which gets hot in and of itself, I didn't feel that would be the best. So I figured the best strategy would be to use a high temp epoxy putty, which can withstand temperatures of about 600 degrees, which should be plenty. You do have to work relatively fast with the epoxy putty, with about 7 to 10 minutes of malleability. Make sure you remove any excess epoxy with a razor, as you want the Cobra Shield to fit flush and flat with the valve cover. Make sure you also have an X-Acto knife to cut out any holes for any mounting points, and make sure you create a template with construction paper of the areas that you want to cover, and then cut the Cobra Shield from those templates, because you have a limited amount of time to work with the epoxy putty, and you also don't want to waste unnecessary material. And for any fraying threads on the shield, it's best to use some super glue just to harden them so you can cut them off with a knife. Obviously, the super glue is not high temp rated, so it's not intended to actually hold the shield down onto the valve cover, just so you can get at the fraying threads and cut them off. Once the epoxy has cured the heat shield to the valve cover, it's important to test the fitment to make sure the additional layer of heat shielding hasn't caused any obstructions with mounting the valve cover flush on the head, and that all the wiring that run on top of the valve cover can still be mounted correctly. Make sure when you're replacing the valve cover that you use a new gasket and use gasket maker in the half moons and let it cure for about 5 minutes. Torque specs aren't as important for the valve cover, it just needs to be properly sealed, but I secured it to 9 foot-pounds, and make sure you use the correct fastening pattern to secure it down. The other benefit of the Cobra Shield is that it's got a chemical and weather resistant coating, so if any oil gets on it, it's not going to ruin its ability to radiate heat away. Now, truthfully, I haven't tested this more than maybe a couple test runs, so I'm not 100% sure how this solution will handle itself in the long run. However, given that the heat shield is rated at 2000 degrees Fahrenheit intermittently and 1100 degrees Fahrenheit continuously, I think I should be in good shape. My only concern is where the head meets the valve cover and whether there's going to be any heat soak that kind of seeps between. I'm going to hope not. I'm going to hope that with the oil line being more secure and the heat shielding around the turbo and the downpipe, as well as the extra precautions around the valve cover, I should be in good hands. But this is my best solution right now. Hopefully you found that educational, entertaining, or anything like that. If you like this video, give it a thumbs up. If you didn't like it, you know what to do. But, you know, if you made it this far, give it a like, subscribe. Thanks for watching. See you later.